So for the sine of angle A, we want opposite over hypotenuse. Regardless of which angle we're working with, 15 is going to be the hypotenuse. That doesn't change. The side opposite angle A is 9. We should reduce that. What would it be? Three over 5. Okay, so I'll edit that. Crescencio, did you have a question?
Yeah.
Okay.
So, like, how do you know which sides to go with?
So we can go back to that mnemonic SOHCAHTOA. SOHCAHTOA. So sine S tells us to use opposite over hypotenuse. Jakeem, redemption on number 2?
Yeah.
12 over 15, good. Cosine C tells us to use adjacent over hypotenuse. The adjacent side to angle A would be 12. The hypotenuse is still 15. That also reduces to be 4/5. Good. Divide them both by 3. Who can tell me the tangent of angle A? Good. Opposite over adjacent. 9 over 12, which reduces to be 3/4. Now, when we go through and find sine, cosine, tangent for angle B, we could reference back to the diagram, and now we're switching our viewpoint. So now the opposite side would be 12. The adjacent side would be 9. The hypotenuse is still 15. Or we did talk about the relationships. There's kind of a pattern that these follow. Lexi, what's the sign of B? It's going to be the same as cosine of A without flipping it. The only one we flip is tangent. So what about the cosine of B? 3/5. It's the same as sine of A. And tangent of B is 4/3. We take the reciprocal of the tangent of A. Now, if you don't remember those relationships, that's fine. You can go back to your triangle and do opposite over hypotenuse, 12 over 15, and then reduce it again. Questions about our trig ratios? Okay, so 10.6 is really bringing everything that we've done back together. It's called solving right triangles. So a lot of what we're going to do in the notes is going to seem very familiar to you, which is a good thing. Should make this lesson easy and help us review, because next week we've got a quiz coming up on Tuesday, notebook quiz on Wednesday, chapter test on Thursday. So there we go, jump in. All right, technically we've already talked about this, but now we're kind of officially putting it in the notes. What if we're missing the angle measure? We've already done this. This is not brand new. If we're looking for the angle measure and given at least 2 sides of the triangle, we can find the missing angle by using the inverse trig function. So we could have sine inverse or cosine inverse, or we've also used tangent inverse. On most calculators, you'll have to use the shift or second key to use this function. Look above the trig buttons. Most will show the -1 exponent like above. It's not really an exponent, but it kind of looks like one. All right, use a calculator to approximate the measure of angle D and angle F to the nearest 10th of a degree. It asks what we notice about angles D and F. Technically, you should already know what, bless you, the answer to that's going to be. What do we know that these 2 angles should add up to? D and F. Okay, good. D and F should add up to 90. So that's what they want you to notice, since we've already done a problem like this before. We don't necessarily need to notice it again, but here it is. The measure of angles D and F will add up to 90. So they gave us all of our sides, which means we get to pick which trig function we use. If you don't have all of the sides, then you have to use a trig function based on what sides you do have. But they gave them all to us, so you get to pick which trig function you want to use. And it really doesn't matter to me. Somebody give me a trig function. Sine, sure. So if we were to take the sine of angle D, what would we say that it should be equal to as a fraction? 30 over 34. Are we all in agreement with that? Okay. So since our unknown, that angle D, is right next to our trig function, and because we just filled in a few bullet points about this, we have to use our inverse trig function in order to get D by itself. So that means I would have D is equal to inverse sine of that same fraction. If you want to reduce the fraction, you can. You don't really have to, though, because where is it going anyway? In your calculator. So it doesn't really have to be reduced. Your calculator is going to be able to do this either way. Let's round to the nearest tenth of a degree. What did we get? Okay. The nearest tenth of a degree, I would agree with 61.9. It should have come out to like 61.9275. So the 2 makes the 9 stay the same. Do we have questions, concerns about angle D? Okay. You did not have to use sine for that. You could have used cosine, but then your fraction would have been 16 over 34. You could have used tangent, and your fraction would have been 30 over 16. So you just have to pick a trig function when you know all the sides. If you don't know all the sides, which we'll see that later, then you actually have to be careful. There's only one option. All right, we found angle D. In order to find angle F, we could use another trig function, or we could subtract it from 90. So I'm fine with just taking the short route on that. 90 minus 61.9 would give me 28.1. So F has a measure of 28.1 degrees. Questions, concerns? Nothing? Ready to move on? Okay. All right, on example 2, we are asked to find the measures of angles P and M to the nearest tenth of a degree. Also, find side N to the nearest tenth. Let's start with the angles because that's what we've been doing. This time, however, we were not given all of the sides right away, so we need to be careful about which trig function we use. Why tangent? Very good. If we're looking at either of these angles, honestly, but we'll start with P. If we look at angle P, we know the opposite side and we know the adjacent side. The only side we don't know is the hypotenuse. So that means we have to use tangent. I know several of you seem to see that right away. Does anybody have questions about why tangent is the only appropriate choice? Okay, so tangent of angle P is equal to what? 5/10. If you want to simplify that, you can. You don't necessarily have to. In order to get the angle by itself, what do we need to use? The inverse. So P by itself would be inverse tangent of 5/10. Again, if you reduce that to 1/2, that's fine. Your calculator can do it either way. Careful with your rounding this time. What do we get for angle P? Good. P is 26.6 degrees. If you want, you could label it in the diagram. You don't necessarily have to, as long as it's clearly stated somewhere for me to find easily. If that's you, make sure it doesn't happen again. All right, we also need to find the measure of angle M. Do you want to use trig or subtraction? Okay, subtraction's usually easier or quicker. So we would take 90 minus 26.6. What would that give us? Okay, so angle M is 63.4 degrees. Now we still need to find little n, or the hypotenuse length. If we wanted to, we could use trig to do that, but there is another way. Can anybody think of the other way we've learned to find the missing side of a right triangle? Very good. Our old friend Pythagoras gave us that handy-dandy theorem. It gave us an equation that goes with it. What's that equation? Good. A squared plus B squared equals C squared. This will come in super handy when you are solving right triangles. If you know two of the sides, you can just use your Pythagorean theorem to find the last one. Technically, we could use trig to do it, but we don't have to. So you've got a whole bag of tricks like trigonometry, Pythagorean theorem. The angles have to add up to 90. You have to think about what to use during what situation. What are we plugging in for A? 10 squared plus 5 squared equals n squared. So make sure that your hypotenuse always gets plugged in for C. If you swapped your A and your B, that's fine, but C has to be the hypotenuse. 10 squared, 5 squared is 25. When we add them together, to get n alone, we must square root. So we could put that n is equal to 5√5. I would be okay with the nearest tenth also, since that was in the directions. So if we have 5√5 as a decimal, what do we get? Or just the square root of 125 as a decimal? Good, 11.2. So I would accept either of those for side n. 5√5 or 11.2. So we just solved the right triangle. We'll talk a little bit more about that towards the end. I did add a couple extra examples to the slideshow because it's more like what your worksheet will look like. But we'll get through the ones that are already on your worksheet. Questions? Need more time on this slide? Okay. Find the angle measures for B and C. Also find side C to the nearest tenth. Okay. Now, in this case, we're missing side C. Is that the hypotenuse? No. So just because our Pythagorean theorem equation a squared plus b squared equals c squared, that does not mean that this c is automatically the hypotenuse. The hypotenuse still lands across from the right angle. Are we all okay with that? These get a little confusing when they label the triangles differently from how we learned them with the theorem. So I will leave it up to you. Do you want to start with the angles or do you want to start with the side? Okay. In order to find the missing side, do you want to use trig or Pythagorean theorem? Okay. If we're going to use trig, we have to find an angle first. That's the tricky part. So if you want to use trig, then we've got to start with the angle and then work our way to the side. If we're going to find the side right away, we would have to use Pythagorean theorem. So what do you want to do? Pythagorean theorem to find the side or trig to find an angle? Okay. So again, you get to make that choice when you're doing these problems on your own. So if you wanted to start off with trig and find a side first, find an angle first, then use it to find the side, you could do that. So what are we plugging in for A? Okay. For B and C. Good. All right. 45 squared is 2025. 53 squared, 2,809. Subtract off the 2025. We get that c squared is equal to 784. Are we all okay with that? All right, to get c all alone, we would have to square root. What do we get for c? 28. So this one does not have a decimal or a radical left over. We just got 28. The nice part about finding a side first is that then you get to pick which trig function and which angle you want to work with, because now we have all of the sides. So let's work with angle B first. Which trig function do you want to use? Sure, you could use sine. You could use any of the trig functions if you know all of the sides. So if we're finding the sine of angle B, what is that fraction? 45 over 53. Good. 45 over 53. In order to find the angle measure, what do we need to use? The inverse trig function. So this time that means sine inverse of 45 over 53. Handy dandy calculators do the heavy lifting for us. We get that the measure of angle B is 28.1 degrees rounded to the nearest tenth. And then in order to find angle C, what should we do? Okay, the easy thing to do would be to subtract 90 minus 28.1. What is that? Sorry. Did I write this wrong? Yeah, it's not 28.1. What is it? 58.1. Okay. Sorry. Did somebody say 28 or was I just looking at the board? I might have just been looking at that board. That other 28. Okay. 58.1. Sorry about that. That's what we should subtract from the 90. And what do we get? 31.9. Okay. 31.9 degrees. Are we all okay with those? I think I just had that 28 in my head from before and just rewrote it. Questions, concerns? Need more time? Okay. The next set, in my opinion, should go really quickly. Give you a second to copy down the original problem. These are the example numbers. So 4, 5, 6, 7, 8. Those are not part of the problem. They're just the number of the problem. If we are looking for angle measures, what should we be using? Inverse trig functions. So you don't necessarily need to write this every time, but angle A is going to be sine inverse of 0.5. Okay, you don't necessarily have to write that on every single one because your calculator is going to do the work for you, but this shows what you should be typing into your calculator. And what do we get for angle A? 30 degrees. If you're finding an angle measure, please remember to put your degree symbol on it. On number 5, what should I be typing into my calculator? Of 0.92. Good. Cosine inverse this time. Rounded to the nearest tenth. What is that? Good. On number 6, what's getting typed into my calculator? Good. Inverse sine of that decimal, 0.1149. Rounded to the nearest tenth, what do we get? Good. 6.6 degrees. It's a pretty small angle. Next one, what's going into the calculator? Good. And this one is a little tricky. When we round it, what do we get? Good. This one will round all the way up to 54 degrees. All right, last one. What's going in the calculator? Inverse tangent of 1.0724. And that one rounds to 47 degrees. Okay, so problems like that are just straight calculator problems. Now, I would stay on the back page of your notes because you should have a big blank space over there for us to put a couple more problems up. Just because we have not seen one quite like... especially number 9. We haven't seen one quite like it. So I put a note up on there. To solve a right triangle means to find all missing sides and angles, which we've been doing already today. I'm going to go ahead and label that last missing side on example 9, since we have to find both of the sides. We could also label the missing side on example 10. You could use a little b if you want, or another x. It doesn't really matter to me what variable we use. Are we all able to at least get the diagrams copied down? Okay. So number 9 is a little bit different from the ones we've seen because they gave us an angle measure to start out with, which was nice of them. So what's going to be the easiest thing to find right now that we don't have written down just yet? Angle B. Good. We got 3 things that are missing. 2 sides, 1 angle. Angle B is going to be the easiest because all we have to do is subtract. So to find angle B, we'll just take 90 minus 32. And we get 58 degrees, so we can fill that in. That part's easy. The next part of this really shouldn't be too new, except for the fact that we're finding both of the missing sides, whereas the worksheet that we did yesterday, you only had to find one of them. So the first thing you need to do is pick an angle to work with. It cannot be the right angle. So do you want to work with 32 or 58? Okay, it doesn't really matter. I would lean towards using the one that they started you off with, but you don't necessarily have to. And do we want to start off with finding x or y? Okay. If we're going to start off with finding x, x is what side compared to angle A? Opposite. That's our opposite side. And compared to angle A, they gave us this 13, which is which side? Adjacent, which means we better be using which trig function? Tangent. Any questions about that thought process? Okay, we know the angle measure, so we're actually going to put that right by the tangent. Tangent of 32 degrees is equal to, what's my fraction? X over 13. These are the ones where the trig function gets put over a 1, and we cross multiply to solve. So when we cross multiply, we have x equals 13 times tangent of 32. When I type this into my calculator, am I going to use the inverse? No, we didn't write the inverse. We're not trying to find an angle. We're going to just use a regular old tangent. What do we get rounded to the nearest tenth? 8.1. Okay, x is equal to 8.1. We could label that 8.1. Now, technically, we have 2 options to find y. We could use trig again, or we could use finding a missing side. We can't subtract. Okay, Pythagorean theorem or trig are our options. I personally would like to use trig again on this one. I don't like using the Pythagorean theorem if one of my numbers had to be rounded. And we had to round that number. Does that make sense? Okay, if you use Pythagorean theorem with a rounded number and then you're rounding another number, it's possible that you'll end up with an answer a little too different from what it really should be. Does that make sense? Okay, so if you have all whole numbers or they gave you 2 of the sides, Pythagorean theorem's fine. If you had to round a side, I wouldn't use it. I heard somebody suggest we use cosine, which I would agree with, because now we've got the adjacent side. Sorry, adjacent is already labeled. Adjacent side and the hypotenuse side. Adjacent, hypotenuse. So cosine of 32 degrees is equal to what? 13 over y. Again, we put cosine over 1. So we end up with 13 equals y times cosine of 32. To get y alone, we have to divide by cosine of 32. And we can type that into our calculator. Rounded to the nearest tenth, what do we get? Good. So up here, y equals 15.3. I'm not saying you couldn't have gotten that answer with the Pythagorean theorem. It's very possible you could have. But there is a chance when we use rounded numbers and then round them some more that our answer doesn't end up quite where it should be. Any questions about number 9? Matt, you all right?
Yeah.
Okay, good. All right, then let's talk about number 10. 10 is more like problems that we've already been doing, where they gave us 2 of the sides right away. So we could start off using trig to find an angle, or we could use Pythagorean theorem to find a side. What would you like to do? Okay, we'll find the side first. So what are we plugging in for A? And for B is just B squared still. C. Okay, 4 squared plus B squared equals 5 squared. To get B squared alone, we need to subtract. And then to get B alone, we would square root. B is equal to 3, which is nice. We didn't have to round it. All right, then we have to find angles A and B. Which one would you like to find first? Okay. If we are searching for the measure of angle A, we know all of the sides. None of them had to be rounded. So you get to choose what trig function you prefer. Sure, let's do tangent this time. So the tangent of angle A would be equal to what? Opposite over adjacent would be 4 over 3. Because we are looking for an angle measure, we need to use inverse. So A is equal to inverse tangent of 4 over 3. 3. 4 over 3. Our calculator says A is 53.1 degrees. In order to find angle B, we could use some more trig, or we could subtract. Subtracting's usually quicker. 90 minus 53.1 is 36.9 degrees. You may have noticed on some of these worksheets that you end up with a lot of the same angle measures frequently. That's because there are only so many right triangles that have integer side lengths. So if your if your triangle had whole number integer side lengths, then you're probably going to start recognizing what the angle measures look like. That doesn't mean you need to memorize them. It's just that, yes, a lot of your answers could end up seeming repetitive. Any questions about any of this? Concerns? Confusion? Warm fuzzy feelings?